In this lesson, we are going to introduce graphing ellipses. And ellipses have a little bit of a different look. They kind of feel a little bit like circles, but instead of it equaling the r squared, you end up having denominators and it's equal to 1. So all these pieces will play a role in trying to graph this ellipse. So we're going to spend this video just kind of talking about what the difference is and what it looks like. So you're going to have a center slash kind of vertex of your ellipse. And this is going to shift left and right. This is going to shift up and down. And then these are kind of like your radius values. But anything that's under the x's are going to take from wherever your center is, and it's going to go left and right. But it's going to go left and right, the square root of that. And then same thing on this, that your b value is going to be your up and down. So you'll definitely need to square root these. So your a is going to equal your left and right from the center, and your b is going to equal your up and down from the center. All right, so you'll definitely have to square root them. So the two different situations we have is, well, if a is bigger, and a is your left and right, if a squared is bigger than b squared, then a is going to be bigger than b. That just means you're going to have a horizontal ellipse. Versus if it's the other way around, you're going to have yourself a vertical, because you're going more up and down than you are left and right. So really, again, these are formulas and things, and there's a way to figure out these vertices, and we're going to talk about figuring out the focal points. I don't memorize any of that stuff. I just kind of build my graph. Is that I start with the center, I do my left and right value, I do my up and down value. That gives me my basic graph of it. And then we do have to do some math in order to figure out where the focal points are. Okay, and so we'll talk about that in a second. So let's say we have some sort of a point that is our h and our k. So our h and k, let's say, puts us here. And then we have an a value that, let's say it puts us out here, and it puts us out here. So that distance is going to be a, and let's say the b value puts us up here. All right. So then we really have enough to draw our ellipse. All right, so that a value would have came from us square rooting the denominator, and if it was 5, then we go 5 in that direction, 5 in that direction. And then if our b value is going to be us square rooting the b squared, which is going to be, let's say it was a 2, so we go up 2 and down 2. So once you have your vertex, your center, you'll just figure out what's the square root of this, what's the square root of this, and that's telling you your left and right and your up and down. The last piece is your focal points. Your focal points are going to be somewhere on the inside. So how do we find them? So let's say it's kind of on the K. To figure out this is called the C value. And to figure out C, your C value is going to be the difference between your denominators. The difference between denominators. So, and that's actually going to be your c squared value. So it's going to be just by taking the a squared minus the b squared, or the b squared minus the a squared. Depends on whichever one is bigger. So basically, hopefully it'll make sense that if you're going to subtract them, you shouldn't get a negative here. So if you need to, then treat it as an absolute value. But really the difference is just find the difference between them. So that'll get you your c squared value. And then c is going to be your actually distance. So it's going to be your distance from the center. So c is going to equal distance from center. Now a couple other terminology pieces are you have these axes, or what they're called. So this horizontal axis, because your a value is bigger, at least in this example, a is bigger than b, that makes it a horizontal ellipse. So this horizontal is called the major axis all the way across. So the major axis is this distance from here all the way to here. That's the major axis. And then the minor axis is going to be the shorter distance. That's your minor axis. So if they gave you a length of 10 for the major axis, that meant you went 5 in either direction from the center. So you can cut it in half and know exactly what your A value is, which means then that meant you had to have a 25 in the equation because it was squared. And then the other last piece of information are some terminology that on the major axis only, these are known as your vertices. So I should not call that the vertex. Vertices. All right. So if you now have, so that pretty much covers everything. And again, there's formulas to figuring out those points, but I don't do that. I just figure out wherever my center is, and then whatever my A is, I know that if I'm going to take this coordinate, I'm going to add 5, and I'm going to subtract 5. I'm going to plot it on a graph, and right away I'll get my coordinates. I don't need to know a formula or anything special like that. Oops, distance from center. And then if we have a vertical ellipse, you would find your center, and then we would go up and down. That distance would be B. Still, it would be up and down. The only difference is the B value is meant to be bigger than the A value this time. So that means you have a vertical ellipse because you have more up and down than you do left and right. So that just means that maybe the A value is only this big. All right, so that helps us draw our ellipse. And then these are your vertices. And then your major axis is the longest. So that's your major. And then this distance would be the minor. And your focal points are always on the major axis. So the focal points would be somewhere in between. There's your focal points. And to find that distance is C. And C is going to come from, this time you'd be finding the difference by doing that. And again, if you get this wrong, just realize that you shouldn't have a negative on it. Take the absolute value of it, and that'll take care of it. So your C value is, again, back to the distance. All right, but it's got to be on the major axis. That's the biggest thing that you got to make sure that you remember. All right, so those are some of the terminology and some of the pieces, and then in the next couple examples, we'll be graphing them.